Now let's go to question number 11. It says a ball of mass 500 grams falls from a height of 10 meters onto a hard floor and rebounds to a height of 7 meters. What energy is lost by the ball due to the impact on the floor? Now, this is a very, very easy question. What you need to do is that at the height of 10 meters, but first of all, you need to change this guy. The ball is here at the height of 10 meters, change this thing to kilogram, that's divided by 1000, that will be 0.5 kilogram. It possesses potential energy, which is mgh. So quickly calculate the potential energy at that height, times 10 times 10. This is going to be 0.5 times 10 is 5, 5 times 10, so that will be 50 joules. So it has 50 joules of energy at that height. When it gets to the floor, it bounces back to a height of 7 meters. That means that it has lost like 3 meters worth of potential energy. What's the new energy here? It's also going to be mgh, 0.5 times 10 times the 7 meters height above the ground. And this is going to be 35 joules. Now, what will be the energy loss like that? That will be the 50 joules minus the 35 joules. So the 50 joules minus the 35 joules, you would get 15 joules. Yes, 15 joules. So that will be the correct answer to that. And this one says a block and tackle system is used to lift a load of 30 newtons through a vertical height of 15 meters. If the efficiency of the system is 60%, how much work is done against friction? Whenever you have a system that friction is involved, especially when you're dealing with mechanics, simple machines, just know that efficiency is work output over work input multiplied by 100%. And in the case of work input, when there is friction involved, work input is going to be work output plus work done in overcoming friction. Everything is going to be embedded together in the work input. So here we can easily get the work output because work is force times distance. And we've been given the load here. The load that was over that they did work against was 30 Newton. So work done against gravity, that is times the vertical height, the distance moved against gravity. That's 15. So if you do that very well, that will be 450 joules. This is our work output. We have the efficiency, so we can quickly calculate the work input. So that will be 60. 60 equals 450 divided by work input times 100. So when you do this, this can cut one of the zeros out. 6, 3 can go in 6, that's 2. 3 can go in 45, that is 15. 15. So we have 150, 1500. So the work input will be 1500 divided by 2, and that would be 750 joules. That would be 750 joules. So don't forget I said that work input is the sum of work output plus work done by friction. So that means that 750, so that means 750 is going to be equal to the work input, sorry, work output was 450 and work done. So work done against friction, work done in overcoming friction will be 750 minus 450, and that is going to be 300 joules. Let's go to question number 13. It says a force of 10 newtons is applied to a spring of spring constant 200 newtons per meter. The slope and the area under this graph obtained when the force is plotted is. Now, when you have this, especially because Hooke's law is going to be obeyed here, force versus extension, this is what the graph will look like. Now, whenever you have a graph, the slope is always the ratio of the vertical over ratio of the horizontal. So in this case, this matches with Hooke's law, which will give us the spring constant. It will give us the spring constant. So the first answer is going to be the 200 newtons per meter. The slope of a force versus extension graph gives gives spring constant. However, the area under this, first of all, the area is going to give work done. But if you look at the area, this is a triangle, and the area of a triangle is half multiplied by base multiplied by height. So half times, what is the base? The base is the extension from this place to this place. Let's quickly find the extension here using F equals KE. So E equals F over K. And what is E? And what is F rather? F is 10. K was 200. If you do this very well, that would be 0.05 meters. So that is the extension. So we have the work done now. Sorry, the area is going to be 1 over 2 times 0.05. And the height, in this case, the height corresponds to the force. So that is 10. So that is 10. 10 times 0.5 is 0.5. 0.5 divided by 2, that should be 0.25 joules. So the closest option there is option B. So it should have been 200 and 0.25. So, but the correct answers are 200 newtons per meter and 0.25 joules respectively. Question 14 says that a YouTube manometer, a YouTube contains mercury of relative density 13.6, kerosene of relative density 0.8, which is poured into one. So this is what a YouTube look like. Don't mind my drawing. It's one of it. So the height of the mercury in the arm is reduced by 1.2 centimeter. Calculate the height of the kerosene. Whenever you see a problem like this, you don't need to worry yourself. Just use rho 1h1 equals rho 2h2. I mean, using the relative density now, we just assume the relative density is the same thing as the density of the object. So for the kerosene, sorry, for the mercury that was there, we have 13.6, and the height of the mercury is reduced to 1.2. So the density of for kerosene, we're going to be using 0.8. So we are looking for the height of this guy. So basically, we're just finding this. This is going to be 13.6 times 1.2. So you have 13.6 times 1.2 divided by 0.8. That will be the height of the mercury. And that's 20.4 centimeters. So that's how you undo question that has to do with the YouTube. Next one says a uniform beam 6 meter long weighs. So a uniform beam, whenever you have a uniform beam, it means that you have something of this, it is 6 meters long. Any uniform beam will always balance at their center in the sense that their weight is going to be acting at their center. That's their center of gravity. So it's weighing 5 kilograms. So that means that it is weighing 50 newtons at the center. This place is going to be 3 meters. This place is also going to be 3 meters. That is because it is uniform. If it is not uniform, don't balance it at the center, please. Now, it is 6 meters long. I've settled that. It's resting on support. So there's a support here, there's a support here. 1 meter from each end. Okay, I think I might have quickly predicted that. So that implies that this place is going to be 2 meters. This place is going to be 2 meters. This place is going to be 1 meter. This place is going to be 1 meter because they say P and Q, they are 1 meter from each end. So we have to break it down like that. Weights of 10 kg and 8 kg are placed near P and Q respectively. So 10 kg, one on each end of the bar. Okay, so they are placed here. Weight of 10 and weight of 8 kg were placed here. Calculate the reactions at P and Q. So it's like we have everything we need now. So reactions are always going to be acting upward. So reaction at P, reaction at Q. Whenever you have questions like this, what you need to do is that you need to choose one pivot and forget about the rest and take the moment about that pivot. So to take the moment about each of these pivots, so let's start with pivot P. So that means that we are covering our eyes, assuming that this pivot Q is not there. So we take our moments one after the other. Let's get all the clockwise moments together. Let me put all the clockwise moments. Now, around P now, 50 Newton is going to be a clockwise moment. 8 Newton is also going to be, oh, that's 8 kg. I didn't convert them. So let me quickly convert them. So this is going to be a clockwise. 50 and 80 are going to be clockwise. So that will be 80 times. And what's the distance from here to here? That will be 5 because everything is 6. And this pivot has already taken 1 meter from this end. So the rest will be 5. So 80 times 5 plus 50 is halfway. But from here to here is 2. So that will be 50 times 2. Now let's look at another guy here. This RQ is going to turn like this. So it's not clockwise, it is anti-clockwise. So that means that we're done with the clockwise moment. 80 times 5 is 400. 50 times 2 is 100. So everything here is going to be 500. Now let's take the anti-clockwise moment. Now 10 is going to give anti-clockwise moment. And it's just 100 Newton rather. Is 1 meter away. So that's 100 times 1 plus the reaction at Q, which is also 4 meters away because from here to here is 2, from here to here is 2. So it is 4 meters away. So RQ times 4. Why are we not taking RP? Because it is exactly at that spot. So therefore, it is not going to have any momentum at that point. So this is going to be 4 RQ plus 100. So when you equate these two together, you solve it. 100 will go to that place and will become 500 minus 100, which is 400. So RQ is going to be 400 divided by 4, which is going to be 100 newtons. And the thing is that sum of all the upward force must be equal to sum of downward force. So 100 newtons plus reaction at P must be equals to 100 plus 50 plus 80. And 100 plus 50 plus 80, that should be 80 plus 50 is 130. That will be 230. So RP is going to be 230 minus 100, and that is going to be 130 newtons. So the reaction at P and Q respectively, they are 130 newtons and 100 newtons. Now let's continue with question 16. Question 16. It says a uniform meter rule of weight 1 newton is pivoted at the 40 centimeters mark. So you have a uniform meter rule pivoted at 40 centimeter mark. So it's weighing 1 newton and it's a meter rule. So the total length of this guy is going to be 1 meter, or we use 100 centimeters. So it's going to be, the weight is going to be acting at the 50 centimeters mark. And so let's say that 50 centimeter mark, the weight is 1 newtons. Then it's pivoted at 40 centimeter mark. So let's put pivot here at 40. A weight of 2 newton is on from the 15 centimeter mark. So let's make this 15 centimeter. A weight of 2 newton is placed there. Where must the weight of 2 newton be placed to balance the rule? So let's assume that the weight is here. The weight 2 newton is here. By the way, you can place your weight 2 newton anywhere. In fact, for the purpose of putting it anywhere, let me place it here. So let that weight 2 newton be here and let it be at the x centimeters mark. So to do this, we're going to take the moment about each of these points. So which ones are going to be clockwise, which ones are going to be anti-clockwise. You can see that only 1 newton will be clockwise here. So that will be 1 newton multiplied by, what's the distance away from the pivot? That is 10. So 1 times 10, it will be equal to, let's take the this first 2 newton is at 15 centimeters. So away from 40 centimeters, 40 minus 15, that should be 25. So that will be 2 times 25 plus, now this guy away is 2 times, it's at x, and this is 40. So 40 away, that will be 40 minus x, that's the distance, multiplied by 2. So I'm solving for x now. So 10 is going to be 2 times 25 is 50 plus 2 times 40 is 80, then minus 2x. So in this place, I can take 2x to this side. So 2x is going to be equal to 50 plus 80 is 130. So 130 minus 10, that's 120. So what would that make x? X is 120 over 2, that's 60. So you can see that x is the position where this guy must be. But I wrongly placed it in this place. But it still later gave me a good result, which is something at this end. So x must be at the 60 centimeters mark. So no matter where you place it, as long as you do the correct thing, it's still going to be correct. Number 17, a string makes 60 revolutions in 15 seconds. Its period and frequency of vibration are respectively. Now, period is the time taken divided by number of revolutions. So this is very easy. So 15 seconds divided by what? Divided by 60. That's 1 over 4. And that will be 0.25 seconds. And good thing is that frequency is simply the inverse of this guy. So that will be the 4 hertz. So this is a very, very simple and straightforward question. So the correct answer is going to be B. Now question number 18. Question number 18 says that a body of mass 20 gram is suspended from a spiral spring. Now, if the body is suspended from a spiral spring, you have of force constant 0.4 newtons per meter. So this one will be 0.02 kilograms, like that. 0.02 kilograms divided by 1,000. Then it is set into simple harmonic motion with an amplitude of this, the period. Okay, we're looking for the period, total energy, maximum velocity, and maximum acceleration of the system. To do this, we can get the period. Period is equal to 2 pi multiplied by square root of m over k. And so that will be 2 pi, square root of m was given as 0.02, k is 0.4. So 0.02 divided by 0.4, then the square root of that, then multiply by 2 pi. So that is 1.41, approximately 1.41 seconds. In the exam hall, if I was answering all these things, I would have chosen option D already. But for the sake of this video, I'm going to calculate. The next one says total energy. If the amplitude is 0.2, energy, total energy in the system will be half Ka squared, where A is the amplitude and K is the spring constant. So that will be 1 over 2 times K is 0.4, then 0.2 squared. So 0.2 squared multiplied by 0.4 divided by 2. That is 0.008. So it's looking like it, 0.008 joules. The next one says maximum velocity. V is omega A. V is omega A. Omega is actually, omega for this particular motion is actually the square root of K over M. And then the square root of K over M, that is the square root of 0.4 divided by 0.02. And since I've gotten my omega, I will just multiply by the amplitude, which is 0.2. And so that's 0.89. That's 0.89. And now finally, to get the maximum magnitude of the acceleration, that is A equals omega squared A. I believe you can do this rest on your own, but the correct option is going to be D. Next one says, number 19 says, the terminal velocity of a ball bearing falling through a viscous fluid is reached when upthrust equals to the weight of the ball. These are not the only two things that are actually in the that are there. We have the upthrust, we have the viscous, and we have the weight of the body. Weight is acting downward, upthrust is acting upward, viscous force is also acting upward. So the best option to go for in this question, like it has stated, is when velocity is uniform. So the terminal velocity of a ball bearing falling through a viscous fluid is reached when the velocity is uniform. So upthrust equals to weight of the ball. That is accounting for only two of these weights. You have left viscous force behind. B says ball accelerates uniformly. That is what happened when the ball just started falling first. Velocity versus time, acceleration uniformly. Upthrust equals velocity of the ball. Velocity is different from upthrust. Upthrust is a force. Velocity is not a force, so they can't even be equal. So the correct answer is velocity, because when you reach terminal velocity at this point, this graph flattens out, which shows uniform velocity. Let's do question 20 now, and we'll continue with the rest later. A plastic floats in water. The density is that with 0.5 of its volume submerged. That means that the volume in mass is 0.5. And floats in oil with 0.4 of its volume submerged. What is the density of the oil? One thing you should know is that for flotation to happen, the weight of the object must be equal to the upthrust. And then weight of the object is going to be, that means that if it is floating in both of them, it's going to have the same value of upthrust. Just that what is causing this upthrust is going to be the difference, because for flotation, weight of the body, the actual weight of the body must be equal to the upthrust. Since actual weight of the body must be equal to the upthrust, then it implies that the upthrust of this person is always constant, no matter what liquid that they have. The only difference is the volume that they will be submerging. So an upthrust is rho Vg. So rho Vg, rho is the density of the liquid, V is the volume submerged, and G is the acceleration with gravity. So if I equate this now, that will be rho 1 V1 G1 equals rho 2 V2 G. The G is going to be the same. So what is rho 1? That is the density of water, 1000, multiplied by what is the volume submerged? 0.5. The density of the second guy is what I'm looking for. What volume was submerged? 0.4. So now I can just say 1000 times 0.5, 1000 times 0.5 divided by 0.4. And the density of that substance is then going to be 1250 kilogram per meter cube. So that's that. We continue with question 21 in the next video. Make sure you like, comment, and subscribe.